Bismillahirrahmanirrahim. Assalamu alaikum. How are you all students? Today this is the 10th lecture of chemistry, grade 10th. The chapter name is chemical equilibrium and the topic name is reversible reactions and dynamic equilibrium. First is reversible reaction. What are reversible reactions? The reactions in which the product can react again to form the reactant. Such reactions are known as reversible reactions. It means the rate of reaction is proceeded in the backward direction. So when reactants converts to product, that product can again be converted to form a reactant. It means the reaction is reversible reaction. However, what is irreversible reaction? There are a number of reactions in which the products do not recombine to form a reaction. Means once a reactant convert to product, that product cannot be again converted into the reactant. So such reactions are known as irreversible reactions. These reactions once completed cannot be reversed easily, and they are shown by the simple line or single arrow which is directed from the reactants towards the product. It means that no reverse arrow can be drawn, means no product converts to reactant again. For example, when magnesium reacts with the excess of hydrochloric acid, the reaction stops when all the magnesium is used up. The magnesium cannot be again converted into the given reactant. So the product cannot be converted back to the reactants. This is an example of irreversible reaction. So when magnesium reacts with hydrochloric acid, magnesium chloride is formed with the release of hydrogen. This magnesium chloride, it means that we synthesized magnesium, the magnesium easily used, completely used, and now this magnesium cannot be converted again into the reactant. So this is irreversible reaction. While in reversible reactions, we use double arrow. It means that product, when reactant convert to product, that product can again be converted into the reactant. So this is the reversible reaction. For example, ammonium chloride when converts to ammonia and hydrogen chloride, that ammonia can again be used in the formation of ammonium chloride. Means ammonia is the product and this ammonia can again be converted into the reactant. So this is reversible reaction. Similarly, copper sulfate reacts with penta molecules of water. In the product, copper sulfate is formed with the release of water molecules. This is also a reversible reaction, that this copper sulfate can again be react with water and form copper sulfate and pentahydrate. Some other examples are when sulfur dioxide reacts with oxygen, it forms sulfur trioxide, and that sulfur trioxide can also again be converted into sulfur dioxide. It means that the reaction is reversible. Second is when hydrogen reacts with iodine, it forms hydrogen iodide, and similarly hydrogen iodide can be converted into hydrogen and iodine. So this is also a reversible reaction. When a reversible reaction occurs in a closed system, that is, no reactants are added or taken away, means that we cannot add any reactant or we cannot remove any reactant from the container. Now the system is closed, so an equilibrium is achieved. In other words, the reaction goes at the same rate in both reactions. So the reaction will be reversible, that first reactant will convert into product and product will not escape out due to closed container or the closed system. That product will again be converted into the reactant. So this is reversible reaction. Now the exothermic and endothermic reactions. In endothermic reaction, temperature increase and more product is formed, while temperature decrease and less product is formed. In exothermic reaction, temperature increased, less product is formed, and the temperature decreased, more product is formed. You know that what is exothermic reaction is the heat release. When heat will release or escape out or removed, then it will form more product. But here, when temperature increase, the less product will be formed. What is endothermic reaction? The amount of heat absorbed. When the amount of heat is absorbed by the substance, it means the temperature is getting increased, and when temperature is increased, we will get more product. Now, dynamic equilibrium, on the contrary, in chemistry, when a system is in a state of equilibrium, the particles in the system are constantly moving. The static means the object in rest, and dynamic mean the object in motion. So, the particles in the system are constantly moving and change even though there is no visible change. We cannot see the change, we cannot see the movement, but actually all the particles in the system are constantly in motion. The rate of the reactants and rate of products are equal. It means that the speed from which reactants move is equal to the speed from which the products are moving. So the rate of reactants and the rate of products are equal. It means that the amount of reactant utilized is equal to the amount of product formed. This is why in the dynamic equilibrium system there is no change that takes place in the reaction system. Now the equilibrium constant. Take a general reaction, that is A plus B will give us C plus D. This is all in gaseous state in a closed container. At first step, the concentration of the reactants, that is A and B, is taken the same and is maximum. So the concentration of the reactants is maximum at the start, while the concentration of the products, that is C and D, is 0 at the start. At first, the concentration of the reactants is maximum and the concentration of products is 0. It means that now reactants will be converted into product. Product concentration is 0, it cannot be converted into reactant. But the reactant concentration is maximum, it means that reactant is in process to convert in the product. So as the forward reaction proceeds, here the forward reaction will proceed when reactant converts to product. So as the forward reaction proceeds, the concentration of reactants decreases as it is converting into product. Now the products have some concentration. So the concentration of reactants decrease and the concentration of products start increasing simultaneously. So the concentration of reactants starts decreasing from maximum and the concentration of products start increasing from 0. With the passage of time, the forward reaction slows down and the reverse reaction speed up. That now the product concentration is greater as compared to the reactant concentration, or the reactant concentration was maximum at the start, now it is decreasing, and the product concentration was 0 and now it is increasing. It means that now the concentration of the reactant and product is equal. The product concentration got increased while the reactant concentration got decreased. Now the rate of forward reaction and the reverse reaction becomes equal. The concentration of both the reactants and products are equal now. So they attain an equilibrium state. Eventually both reactions, that is forward and reverse, attain the same rate. It is called as dynamic equilibrium state. So here first reactant will convert into the product and then the product concentration will be greater and converted again into the reactant. So this is the reversible reaction and the rate of forward reaction is equal to the rate of reverse reaction. How? That reactant concentration start decreasing gradually while the product concentration start increasing gradually from the 0. So at a stage in which rate of forward reaction is equal to rate of reverse reaction is called as equilibrium state.